Welcome to another fun-filled video of math. This is Math Nerds on a Road Trip! Woo!
30 a.m. Are there any gremlins out there ready for some math?
Yeah! That was for you to say.
Oh, yeah?
Yeah, no, me. You know what? Okay, hey! Alright. Say hi. This is our guest speaker today, Kelsey Westall. Yeah!
Welcome.
This
Hi.
is Diana Morales.
Hi.
Yes, we're going to periodically film her, but she did not agree to this.
No, she didn't. Alright, so I've done some calculations here. It's going to take us 161 miles to get to Houston. So I need to think about the rate of change, the miles per hour that we need to go. So I got to put our 0, 0, that's our y-intercept, and a little bit of this, and a little bit of that, and a stop by this tree, and maybe a Buc-ee's, and there's a traffic jam. And with all of that, it's going to take us, if we want to go 1 hour, 161 miles per hour is how fast we're going to have to drive. Do you think we can make it?
Yeah.
Okay, good. Let's do it.
So let's take a look at Kelsey's work here. As you can see, we have the y-axis where it's distance, and you can see it's split up into intervals of 20 miles per hour, 20 miles rather. And on this side, we have the amount of time in hours. So you have in increments of 20 in hours, and she wanted to get to Houston in a total of really 161 miles in 1 hour. Therefore, as you find the slope would be y2, which is 160, over y1, which is 0, divided by 1 minus 0 is 161 over 1, which is going to be 161 miles per hour. So we actually figured out the amount of time it would take if we want to get to Houston in 1 hour. So it's going to take, you're going to have to drive 161 miles per hour.
Is that a no?
I think that was a no.
No, you're right. We're trying.
So this is going to be our rate of change indicator for the trip. Oh no, that's the RPMs. There. This is our rate of change indicator for the trip in miles per hour. So if you want to know how you get your rate of change, that's going to be your slope. For our slope for our trip is going to be constantly changing, as indicated by this. Right now we have a slope of 0 because we're not going anywhere. But soon we're going to have a slope of probably 300 miles per hour. So here's Miss Westall. Miss Westall is actually doing text messaging right now. So when she started,
Instagram.
okay, so when she started, she had 2 Instagrams, right? She gets them at roughly, she gets another 3 Instagrams every hour, right? Let's actually turn the graph this way so we have more room to work with. So she started with 2 Instagrams. She gets approximately 3 Instagrams every hour. So that's going to be a rate of 3 over 1. So at this rate, we have approximately 2 hours to get to Houston. So 1, 2, at this rate, in 2 hours, this would be the graph that represents the number of Instagrams that she gets at this rate. And so our graph then would be y is equal to 3 over 1x plus 2, which is really just y is equal to 3x plus 2. So if we want to solve for 2 hours from now, right, we could look at the graph if we wanted. We could solve it that way. But the other thing we could do is we could actually plug in 2 for x. We get 3 times 2 plus 2 is equal to y, and we can figure out how many Instagrams is she going to likely have. This is a prediction. Y is equal to 6 plus 2, which is equal to 8. So in 2 hours, she's likely to have 8 Instagram posts. Let's see.
Alright, so we are going to talk about graphing lines. the first thing that we need to do is we need to figure out where to start. And I know a good place to start on the y-intercept. The y-intercept is mentioned by the letter b. It's usually the number at the end, but it's really just the constant that's added or subtracted on. Today, our y-intercept is 1. Since I needed a place to start, I'm going to put a star on the y-axis for number 1, because that's my starting point. So there's my starting point, and now I need to figure out how I'm going to move. You know what tells me how to move? The rate of change, otherwise known as the slope, or the letter M. So here it is, my rate of change. Now this morning, we had to wake up very, very early. We had to rise in the morning before we went for our run. Just kidding, we don't do that. But if you were, you would rise first, and then you would run. So from my starting point, I need to rise 2 and run 3. That means I'm going to go 2 up in my y direction, 1, 2, and 3 over to the right in my run direction, 1, 2, 3. And that's my next point. It's very important that you start from your starting point, or your line will be all screwed up. Next, I'm going to do one more point. Rise 2 over 3 to the right. I like to think of that as 2 over 3 because 2 is literally over 3. So now we need to connect with a straight line. I'm on a road trip, so I don't have anything to do that with. But just imagine that this line is really straight, going through all of these points. It's super straight. You see that? Very, very straight. And that's how you graph a line when the slope is positive. Stay tuned for a negative slope. It's now time for the negative slope. Negative. So negative. I'm sorry, I'm very serious mathematician. So, negative slopes. We still have to find a starting point. It's the y-intercept. That means it's the place where it crosses the y-axis. This one says 7, so I'm going to count up 7 from the origin. 1, 2, 3, 4, 5, 6, 7. That's my starting point, so I'm going to put a star so we don't forget. Now from that starting point, we've got to move. We've got to move. This is negative 5 over 3. So you might think, let's rise negative 5. But you're wrong. You can't rise negative 5. Instead, we're kind of going to fall 5 down. 1, 2, 3, 4, 5. But unfortunately, we're not done. We still have to run. So let's run 3. Which direction should we run? To the right. A 1, a 2, a 3. Wow, this is exhilarating. One more time, fall 5. Run 3. Yippee, let's draw a straight line to connect our points. Isn't it fun graphing negative slopes? Hello, welcome. We are going to graph the line y equals negative 2/3 x minus 4. So our y-intercept is minus 4. I'm going to be the first point, the starting point. Starting right here from the origin, I need to go to negative 4. So I'm going to scoop back. 1, 2, 3, 4. I'm the starting point, but now I need to move. So my friend and your friend, Ms. Morales, is going to get our next point by following the slope. Minus 2 over 3. Back 2 over 3. Oh no, Ms. Morales, Can we make another point?
We can't.
We're gonna have to do the complete opposite. So the math department head, Mr. Christmas, is coming in to save the day. From my starting point, he's gonna do the opposite. Up 2, backwards 3. Wow, if we make a line with our bodies like this, we graphed y equals negative 2/3 x minus 4. And that is math for gremlins, everybody.
All right, I hope you enjoyed that time with Mrs. Westall as she was explaining the various concepts to you. We're going to actually go through this part quite quickly. I'm actually going to hide a couple things just so that it doesn't freak you out. We're actually just going to graph a couple lines. You learned how to graph lines with her, so let's go ahead and put it into practice now. I want you to go ahead and pause the video and try this one here. Y is equal to 6x plus 3. Alright, hopefully you actually did pause the video and try it. So what I'm going to do is I'm going to start off once again. My form is, the slope-intercept form is y is equal to mx plus b. And if you remember, b is the y-intercept, which we call the starting point. So in this case here, I'm going to put a star on 3, since that's my starting point on 3, right? And then my movement in this case is 6, or rise of 6 over a run of 1. So rise over run, so 6 over 1. And I'm just going to go ahead and start now. I'm going to do a rise of 6, which is going to be 1, 2, 3, 4, 5, and 6. And over 1, which is going to be right here, right? So remember, we told you if you cannot do 2 in the same direction, if I try and do another 6, I'm going to be off the paper. So now I'm going to start here. I'm going to do the reverse. I'm going to go down 6. 1, 2, 3, 4, 5, and 6, and over 1 in the opposite direction, right to the left one. And that's, now I have my 2 points. So I'm just going to go ahead and take, and I'm going to connect those points. Bam. And then I'm just going to go and make it here too. Okay. And that right there is my line. I can go ahead and draw it like that, and that's my line for y is equal to 6x plus 3. All right, let's go ahead and try another one. So now we're going to get rid of that one. Let's do this one here. Y is equal to 1/3 x plus 10. So once again, my starting point. Go ahead and give it a shot. Start at the starting point. All right, hopefully you actually did pause it and give it a shot. If you didn't do that now, yeah, we mean right now. All right, so we have plus 10 here. And so I'm going to start at my plus 10 y-intercept, right? Because that's my y-intercept. So I'm going to draw my cute little line there. And then I'm going to do a slope of 1/3. So in other words, a positive slope where I go up 1 and over 3. So I go up 1 and over 1, 2, 3. And I'm going to go ahead and plot my point right there, right? I actually don't like the way that point came. There we go. And now I'm just going to take and extend it through my point. There we go, just like that. And then I'm going to go ahead and do it the other way too, just so I have a continuous line. And I have y is equal to 1/3 x plus 10, and that's my line for it, right? So far I plotted 2 lines. I plotted this one and this one here. You'll notice both of these slopes are positive, so it makes sense that both of these are like uphill lines. This one is far steeper than this one, right? And that makes sense because the slope was actually much greater than 1. This one, the slope is less than 1 even, so it's a fairly flat slope, right? Not quite flat, but head in that direction. Not very steep is what I meant to say. So now we're going to do problem 3 here. Y is equal to negative 2/3 x. Now we're going to see we have a negative slope. So our line instead of going uphill, it should go downhill now. So I'm just going to change the pen color so it matches. And let's do it. So I have negative 11 now is my... Negative 11 is going to be my my y-intercept, I don't know if you can see it there. There we go. Let me try and make it a little darker. Yep, negative 11, right? And I can't actually go the negative 2/3. I have to go down 2 and over 3. That's going to put me someplace over here, right? But I can't actually get an accurate point because I don't have the grid, right? If I had the grid, I could, but I don't. So in fact, I have to do the opposite now. So instead of going down 2 over to the right 3, I'm going to go up 2 and to the left 3. 1, 2, and 3. And I'm going to put my point there. And as we've told you, you always want to, generally speaking, go 3. You want to make 3 points, so you want to do this movement twice, and that's just so you can get your points farther apart. So once again, I'm going to go up 2, 1, 2, and over 3, 1, 2, 3 in the opposite direction. Once again, I'm doing that because I couldn't do it down here, so I had to go backwards and do the opposite to get the points back here. So I'm just going to go ahead and mark my line there, and my line is going to also go right here, and that is my beautiful, wonderful line. Y is equal to negative 2/3 x minus 1 and 11. Now you'll notice the negative 11 was the starting point. I didn't draw a star this time. You don't have to. It's just something to help you guys remember. And negative 2/3 is a negative slope. Yeah. So all right, let's go on to the negative problem 4. So we have red. Y is equal to negative 4/7 x plus 8. So in this case here, I'm going to start at plus 8. So that's going to be my y-intercept, my starting point, right? That's my starting point. I actually get rid of it so I can draw a nice, very, very neat line. But if that's what it takes for you to remember, you do it. And then I'm going to go negative 4/7. So I'm going to go down 4. 1, 2, 3, and 4. And over 1, 2, 3, 4, 5, 6, and 7. And this is my other one. Then I can try again. Negative 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. Oh, I'm running out of room again. So this one, once again, I'm going to have to do the opposite. So I'm going to go up 4, 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, and 7. And I'm going to make my last point right here. And as you can see, this is my line. Makes sense. It goes through my starting point, and it's going to go all the way back to here. And that's my line. That is a horrible end, but you get the idea. All right, so there we go. And that's, once again, a negative slope, so it makes sense. It's a negative slope here, and it has a y-intercept of 8, right? And finally, I'm going to do the last one. The last one is problem 5. Problem 5 is, and hopefully this makes sense after Mrs. Westall went through that with you in our Math Nerds on a Road Trip video. So here I got problem 5. I got y is equal to 12x plus 4. Once again, plus 4 is going to be my y-intercept, so it's going to be right here, right? And I have to go up 12 and over 1. Well, as you can see, I can't go up 12 and over 1. So I can go down 12, though, and to the left 1. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And once again, I'm just doing the reverse of this, or the opposite of this. And I'm going to go over to the left 1 in this case. And this right here is my slope. And as you can see, that's a very, very, very steep slope. Very steep indeed. And I'm just going to go ahead and mark that there and mark this on this side, and that right there is my line. And it makes sense that this is a very steep slope because this is much greater than 1. It's a positive slope, as you can see, and the y-intercept is 4. This is my y-intercept. It's almost a little hard to tell because of this, but that is the y-intercept right there. And as you can see, we have done a few examples. There are some examples with positive slopes. So this one has a positive slope, this one has a positive slope, and this one also has a positive slope. As you can see, blue, purple, and gray. The purple, the blue, and the gray all have uphill slopes. The two that have down slopes are the red and the green, and that should make sense by the equation, and in fact it does. Negative 2/3 and negative 4/7. Anyway, I hope you had a great time with Math Nerds on a Road Trip, learning how to graph equations, and I hope that it made a lot of sense to you. In another video, I'll handle special cases like undefined slopes and and horizontal slopes, flat zero slopes. I will do that in another video, but for now, I hope this made sense to you, that you understand how to graph the y-intercepts as the starting point, and how to use the slope, the movement, to graph the rest of the line. And once again, always try and get 3 points so that they're far enough apart that you can draw a really good line, and always use a straight edge. Anyway, once again, I want to commend you for doing such a great job. I want to commend you for just taking ownership of your education. It really is amazing when you guys do what you need to do to be successful, and we just wanted you to know that we're proud of you. But more importantly, you should be proud of yourself, because you're doing something that's really going to help you not only in our class, but just in other classes. When you're willing to take your education by the proverbial horns, it helps you in a lot of ways. So I wish you the very best. You're amazing. Here's a smiley face just for you, and have a great and wonderful week. Take care.